This is Team 4, and our team member are Yihao Li, Gautam Harbour, and Yanchen Zhou. And here is our final presentation of our final project. For the introduction, uh, as we know, our final project is to design a cloud system for a company called LedgerOps. LedgerOps is looking for an efficient and cost-effective way to store large data. The data are required for the analysis and exploration. Ensuring the data is secured is very important for this solution. In addition, ease to use are also another important thing for this solution architecture. Now we come to the requirements. There are three parts of the requirements. First one is the data. We need to storage very large data, and their requirements said we need to store like 20 to 30 terabytes of data within a growth rate of 25% per year. Another one is the architecture. Architecture survey must be multi-tier to support a needed-based activity model, such as the bench or real-time can be real-time analysis. And the third one and the last one is we need to give a cost profile for our architecture. So according to our requirements, we can see there are three parts like we need to do the data storage, and we need to do the real-time analytics, and also we need to show our data to our end user. So our team chose to use AWS as our cloud platform. So because in the AWS it have a service called data lake, including like you can see like the real-time data movement, like analytics, and it has storage large data. So it's a very useful thing. We want to use it to build our cloud platform. Now here comes to the high level architecture. So firstly, we divide in four parts. One part is the data source. We want to get our data from such as the EC2 log survey or other files, all kinds of data. And then we need to have a data storage. So the Amazon S3 can do these parts. And for the data analytics, we can see we use the Amazon Kinesis and Amazon EMR. And for the data exploration, we have the Redshift, the Elastic Service, and the Amazon Athena. So after we make a implement of our system. So from the data flow, we can see we use EC2 log server as an example data source to show how the data flow in our system. So the data from the EC2 server is first we store it in the S3 storage. And if the end users want to do some analytics, so we can use the Amazon Kinesis data warehouse to analyze this data, and then our system allow this data, which is being analytics, to also store in S3 for the further user, and you can see another way for this data we can use the Elastic search to send to our end users, and they can see that. So next, we are welcome to my friends Harbor to introduce about the cost of our solution architecture.
So now let's talk about the cost estimate. As we can see in the slide here that we compared the cost estimate on the Linux platform. So if we take the RAM as 16 gigs, storage as 20 gigs, CPU cores as 6, transfer out limit as 10 terabyte, transfer in as 10 terabyte, subscription for 1 month. So the Amazon Web Services will cost us $1,168. Microsoft Azure will cost us $1,130. Google Platform will cost us $1,274. Now comparing the cost on the Windows platform, the RAM as 16 gigs, storage as 20 gigs, CPU cores as 6, and then transfer out and transfer in limit as 10 terabytes, subscription 1 month. So the Amazon Web Services will cost $1,433. Microsoft Azure will cost $1,250. Google Platform will cost us $1,559. Coming to the security. Security is the shared responsibility between AWS and the end users. So it is divided into two subpods, which is known as the security of the cloud and the security in the cloud. So the security of the cloud is Amazon Web Services is responsible for protecting the infrastructure that runs AWS services in the AWS cloud. It also provides us with some other services like S3, IAM, Amazon CloudWatch, Amazon CloudTrail, the key management services, which can also be used securely over the platform. The effectiveness of their security is regularly tested and verified by the third-party auditors as a part of AWS compliance program. So security in the cloud is basically end users' responsibility to determine the AWS services that we use. We are also responsible for a factor which includes protection of the sensitive data, including personal as well as organizational data. We also need to check the laws and the regulations of the different geographical areas. So now my friend Yang Chung will talk about the recommendations.
So why we use AWS and recommend this project. Many companies are hoping to use data lakes to analyze data and tap the potential value of data to drive business growth. However, their on-premise data center will have a lot of difficulties in their construction process, especially the huge cost. So they decided to migrate their data lake construction to AWS. AWS can provide a complete set of tools required by the data lake, and more importantly, it can provide reliable security for data lake. Although not being the cheapest one in three main cloud platforms, AWS has a great advantage in agility compared to Google Cloud Platform and Microsoft Azure. Services AWS offer cover from their basic foundation services, computing services, storage, security services, to big data services, IoT, and machine learning. AWS almost complete coverage of all products and services about data lake. In this project, we think our architecture is a good choice. The architecture is divided into three layers: batch layers, speed layers, and serving layer. Batch layer and speed layer are used for batch calculation and real-time calculation, respectively. And then there is a serving layer in addition to the two calculation. The serving layer combines the results of batch calculation and real-time calculation and provide data to analytic tools. In this case, we have a large amount of structured data, semi-structured data, and unstructured data. Thus, the architecture is perfect for this job. With the data continues to grow, our architecture should be further improved. After storing the data into 3 buckets, we need to process the data. In the data lake architecture, Amazon EMR is the most common tool for ETL. With the help of Amazon EMR, we can process all the data collected into S3 bucket through Hive, Spark, and other engines, and then return the processed data to the S3 bucket, which are analyzed by tools. Throughout the data lake, security is paramount. In the AWS data lake, AWS provides many effective security services, including AWS IAM, CloudWatch, CloudTrail, key management services. We need to make full use of these security services in the next step. My friend Gautam will talk about summary.
So thank you guys. The summary is all about the project aims to ingest the streaming log data, then aggregating the data and persisting the aggregated data so that it can be analyzed and visualized. We created a complete end-to-end system that integrates several AWS services. We analyzed the live stream Apache Access log data and aggregated the total request for each HTTP responses type every minute. To visualize this data in near real time, we used an user interface UI tool that will chart the results. Thank you so much. Thank you. And these are our references from where we took our information.